Okay, so we're going to discuss some quadratic inequalities, right? Before we discuss quadratic inequalities, let's just look at simple linear inequalities that we've dealt with before. So let's have a look at the first one. We have 2 in brackets x minus 5 is less than 9, and we need to solve for the values of x that would make this statement true. So we'll first expand the brackets out. And then we'll just move the 10 to the other side, just like a normal equation. And we will get 2x is less than 19. And to solve for x, we just divide both sides by 2. And we'll get 19 divided by 2, which is just 9.5. So any value for x that is less than 9.5 would cause this statement to be true. All right, let's look at another example. We have 5 minus 3x is greater than or equal to 17. So usually what we'd do is we'd move the term without the x to the other side, and we'd get minus 3x is greater than or equal to, we're subtracting 5, so 12. Now we need to remember when we divide by a negative number or multiply by a negative number, we need to change the inequality sign. So we'll have x is less than or equal to negative 4. Okay, so one very simple way to show why we need to change the inequality sign is to do the same equation but just in slightly different way. So instead of moving the 5 over, I'm going to move the 3 over to the other side, just like an equation. And now I'm going to move the 17 over to the other side, so I'll get negative 12. And then dividing through by 3, I will get, you can see that the inequality is facing away from the 4, right? Which is exactly the same as this one here, right? So that just shows why we have to change the inequality when we divide or multiply by a negative sign. It's just like moving the inequality over to the other side of the equation. Okay, now when we solve quadratic inequalities, like this one here, x squared minus 3x minus 4 is greater than 0. If we consider what the expression is saying, it's basically saying we have this quadratic, and we want to know the solutions of this quadratic, the x values, where this quadratic would give anything greater than 0. And basically, that's all the positive solutions. So we can demonstrate that visually by graphing this quadratic. So we'll just factorize to find the intercepts. So that'll be, that's going to be negative 4 and plus 1. And we can see we're going to have intercepts at 4 and negative 1. Okay, so when we are graphing these inequalities, what it might be easier to do is just change the equality to an equal sign just temporarily, and we can solve for some solutions. Right? And actually, for the purposes of solving the inequality, that's all we need. We don't actually need anything else. Okay, so we have a intercept at minus 1 and at 4. Now going back to the inequality, we're looking at all the values of x where the function is greater than 0, right? And anything greater than 0 means it's positive. And we can visually see that the positive solutions are over here and over here. And now let's consider the x coordinates where that happens. Well, we can see that that happens when x is greater than 4 or less than negative 1. And so to solve our inequality, x squared minus 3x minus 4 is greater than 0. We could say that that's when x is greater than 4, because if x is greater than 4, we have positive solutions. Or x must be less than negative 1. Because when x is less than negative 1, we also get positive solutions, and that's what we're after. Okay, let's look at another example. Now, it would be very tedious if we had to always graph a quadratic if we were trying to solve a quadratic inequality. However, if we go back to the one where we've graphed it, you can see that in actual fact the only thing we were interested in were where the intercepts were. Because if we know where the intercepts are, we can basically determine where the graph is negative and where the graph is positive. And generally when we're solving an equation, we make it equal to 0. And when we make an equation equal to 0, if we have a negative in front of the x squared, we just divide it out, because 0 divided by a minus number remains 0. So let's have a look at this and see how we could solve this without graphing. So the first thing we're going to do is we're going to factorize this inequality. So we're going to get x, so we'll have 2 and 7, so x plus 7, x minus 2, right? And now what we're going to do is say, well, we want to know what the critical values are. Okay, so critical values are where is the quadratic intercepting the x-axis, right? Because that will determine where the positive and negative solutions are going to be. So critical values are basically the solutions when x is equal to, or when the equation is equal to 0. So we'll have a critical value at -7 or at 2. Those are what we call our critical values. And what we can do from here is just draw a very simple straight line, and it doesn't really matter where we put these. We're just going to put our intercepts on, our critical values, in numerical order. So negative first and then the positive solution. And if we have a look at our parabola, it's x squared. It's a positive parabola, meaning it has a shape something like this. We're not interested in the turning point. We're not interested in the y-intercept. We're just interested in where the graph intersects the x-axis. Because now we can see where the positive solutions are, and we can see where the negative solutions are. Okay, and in our function this time, we've been asked to find the values where the function is less than 0. In other words, where are the negative solutions? And we can see that this occurs between -7 and 2. So how we would write that as a solution is -7 is less than x, which is less than 2. Okay, and we are carrying the inequality sign over from the original question. So for instance, if the question had said x squared plus 5x minus 14 is less than or equal to 0, then our solution would have been -7 is less than or equal to x is less than or equal to 2. So it's important that you carry the inequality from the original equation.